Welcome back, sports fans. Today we're going to be talking about kinematics and practice problems. So we're going to get some more work here with these kinematics. You're going to learn about the importance of creating a list. You'll also learn ways to decode story problems. All right, a little quick review here. What is the average acceleration of this object? Well, when we're asking for average acceleration, what we're asking for is for you to go to the equation that's being listed. That's probably the easiest way because, again, if they're saying average acceleration here, they're talking about the slope of the line. So this right here is our average acceleration, and that would be 1.9 meters per second squared. Now, I did round there a little bit. What is the actual acceleration between 5 and 6 seconds? Well, now this is different. 5 and 6 seconds is, I'm going to draw a line right there that tells me exactly what was happening between 5 and 6 seconds. So this is not the average. I want to use the actual points. When it says actual, I'm going to use the points. Obviously, because it's a flat line, it's 0. But let's go ahead and write down the ordered pairs for that. It looks to me like this would be 511, and this right here is 611. So between those two then, I'm going to label this as x1, y1, x2, y2, and the slope then becomes 11 minus 11, 6 minus 5, or 0 over 1. So as we said, it's 0 meters per second squared, and that makes sense because it's a flat line. When is the acceleration negative? Well, the acceleration would be negative when we have a downward slope. So as I'm seeing here, little technical difficulties there, we would probably have a negative slope. Looks to me like right about here. All right, when is it positive? Well, from here, that's positive slope, so that's positive acceleration. And then between 5 and 6 seconds is when it's 0. Find the displacement of this object between 2 and 4 seconds. Displacement now is going to be the area underneath the curve. I'm going to break this into two problems here. Again, the areas here, I've made it 5, it's 1, it's 2 high there, it's 1 across. So I've broken this into some triangles. 5 by 1, this has an area of 5. 5 by 1, this has an area of 5. This is, the base is 1, the height is 3, so it's 1 by 3 divided by 2. Because it's a triangle, so that's 1.5. And then 1 times 2 divided by 2, because it's a triangle, is 1. There's 5, 10, 12 and a half meters. All right, the first thing here, you're designing a testing facility of Walker spoils. One kind of dragster he is producing must reach a speed of 90 meters per second and can accelerate at 21 meters per second squared. If the drag strip is 100 meters long, can this dragster reach 90 meters per second? Well, first thing I'm going to do is I'm going to create a list here of what they're giving me here. One kind of dragster he's producing must reach a speed of 90 meters per second. So I'm going to say that the velocity final equals 90 meters per second. We're talking about a drag strip, so common sense tells me velocity initial is 0 meters per second. The acceleration is 21 meters per second squared. Drag strip XF equals 100 meters. Because it's a drag strip, I can say XI equals 0. Question becomes then is, can this dragster reach 90 meters per second? Well, I'm going to find out, what's the fastest it could be. And what to do that is I would have to find out the velocity final of this dragster after 100 meters. Well, this problem doesn't give me any time. Nowhere over here have I listed time. So right away that tells me I'm going to be using this equation right here. So again, I'm going to leave this part in the equation. That should be a squared up there, not a big 2, to find out again what is that velocity final. Initial would be 0, so that goes away. A lot of times in physics we won't put stuff in that we don't need because it just simplifies the problem. So that means I can get rid of the plus, and now we have 2 times 21 XF is 100. Well, hey, I'll let you guys work it from there. I'm not going to go any farther than that. Okay, in this problem, Jordan Gator in the 200-meter dash is running 12 meters per second with 100 meters left to run and can run no faster. S. Kimmel has 105 meters left and is running 11 meters per second. S. Kimmel still is able to accelerate at 0.9 meters per second squared. How long does it take for Jordan Gator to finish the race? Well, time here. How long does it take? How long in this problem isn't a distance. Long is referring to time. So I'm going to have to use a problem that involves time. So right away that eliminates this one. All right. It also tells me that he can accelerate. He can't run any faster, so he's not going to be able to accelerate. So his initial speed is going to be his final speed. So there's not going to be a change in speed here. This isn't about a change in speed. So what we have here then, I'm left with, is this bottom equation. Let's go ahead and make this chart. All right, so I can say that XF, in this case, he still has 100 meters left. So we're going to say he's going to run 100 meters. We'll really never use this 200 meters. Just he's running a 200 meter dash. His initial speed is 12 meters per second. His acceleration is going to be 0 meters per second squared because he can run no faster. All right. Well, at this point then, we want to know how long is it going to take for him to finish the race. So, and it should actually be an X, not a Y. That's all right. In XI, we can say where he's starting is 0. So XF is 100. XI, again, remember I told you, things that have zeros in them, we typically won't put into the equation because it just kind of complicates it. We want to write it in its simplest form. His initial speed is 12. His time we don't know. And then it's going to be 1/2 A, but A is 0 again. So that anything times 0 is going to be 0. So that'll really cancel out all that. So J Gator's time is going to be about 8.3 seconds. How long does it take S. Kimmel to finish the race? Well, S. Kimmel, the nice thing about him, or things, it's right down, not the nice thing, but things we can learn about him, his XI is going to be 0 if we say they're both starting in the same spot. His XF is going to be 105. His initial velocity is 11 meters per second. It also tells us, though, that he's going to be able to accelerate at 0.9 meters per second squared. So, again, this is X, not Y. The top equation doesn't do me any good because I don't know his final speed. I know the initial speed of Mr. Kimmel, but I don't know his final speed. This one here, this one doesn't even have time in it, so I'm not going to use the second one. I'm left with the bottom one here again. I get 105 equals, again, the initial we're going to say is 0. His initial speed, we're not going to put V in there. His initial speed is 11 T plus 1/2. His acceleration is 0.9 T squared. So what we do here then, and I'm not going to go through the steps how to solve it. I will show you there's some things you can do on your calculator, your school calculator. You can go online. What I keep on my phone is an app. It's a free app. It's called Equation Solver. Get Easy Solution, and you just type it in and scroll all the way to the bottom and it gives you the answer. Yes, I want you to get the answer. I don't want to spend time teaching you how to get the answer. I want to teach you what to do with the answers. Okay, and this next problem says, how fast was Jay Gator going at the finish of the race? Well, we want to know a velocity final. That's how fast he's going at the end. So this bottom equation doesn't even have a VF in it, so I know I'm not going to use this one. So now I can use the top one or the bottom one. Well, or the middle one. I'm going to try the top one here first. Do I know his initial velocity? Yes. Do I know his acceleration? Yes. Do I know his time? Yes. So what we find out here then with this problem is that Jay Gator was going 12 meters per second. Well, some of you said that, well, duh, Mr. Kimmel. He was going 12 meters per second and he can't run any faster. But here is the algebra to back that assumption up. So again, the bottom equation doesn't give me a velocity final, and that's what I'm trying to find, is how fast was Mr. Kimmel going. And I'm not going to use this equation because it's a much complicated. I'm just going to use my top one here. The VF, I don't know yet. I know the initial speed was 11. I know the acceleration was 0.9, and the time was 7.3 seconds. So when we punch this in here, we get an answer of 28.57. So Mr. Kimmel's final velocity was going 28.57 meters per second. Hey, I hope that was beneficial for you guys. I'll catch you guys on the flip side.